When we start to draw things using a basic shape idea, we can think about those basic building blocks of structure. So a cube. If we're drawing a freehand cube, or indeed constructing a cube using something like Illustrator, and the first thing we need to be mindful of is that this top of the cube, of course, will be undergoing perspective transformation. In other words, this line and this line will appear to be converging at a point on the horizon. This line and this line will also be converging to a point. Now, this is a freehand drawing. We don't necessarily need to calculate exactly where the horizon is, nor indeed our vanishing point. But if we've roughly got a sense that these will connect together and these will connect together, then our cube will look fairly realistic. If we start to draw the side of the cube, if we copy and paste that and bring that over to that corner, and that corner, if we then draw our lines between those points, what we see is that this line is no longer parallel to this line. And in fact, the nature of the illusion is such that this appears to be a slope on the cube. This, in order for this to look more convincing, we would need to remember that this front line is actually closer to us than these two sides of the cube. So in fact, this distance would be longer. Then this angle would come down lower, and this angle will come down lower still. Going back to this point, and then we get more of a sense that this line, and this line might meet at the same point on the horizon. This line, and this line might also meet at the same point. Now that's if we're struggling with the idea of perspective, but we can draw cubes in other ways. I'm going to select all of those for the moment and delete. I'm going to start off this time with drawing a square. I'm now going to copy that square and produce another square. I'm now going to take my line tool and draw a line from each corner to each corner. Now at the moment my line quality is quite thin, so I'm going to select all of those and make them a little bit more visible. Now when you look at this drawing, the nature of the drawing, which is basically a series of straight lines, plays an optical game with the viewer. This front square can appear to be in front of you, but also this square can appear to be in front of you. You can flip perceptually between one and the other. In this instance, with this as the front face, this becomes the top. With this as the front face, we're looking underneath the cube with this at the bottom. So we get this perceptual shift. Now we can perhaps increase the illusion of that plane coming forward by making this a slightly darker line. And lines which are darker or thicker have a tendency to come forward. But what we've drawn here is a basic method of using oblique projection. So oblique projection largely is based on the idea that a square is a square and our angles tend to go off at 45 degrees. Now these aren't 45 degrees, I've drawn these freehand. Now if we look at that object, if we use oblique projection as a drawing system, we tend to produce quite static looking structures. If you look at Paul Noble's drawings, you'll see that most of his drawings are built using an oblique projection system. Another way of drawing a cube is to think about the idea of an isometric projection. Now isometric tends to work on the idea of a 30, 60-degree model. In other words, if we were to draw a straight line for the moment, I'll make that again a smaller, thinner line. If we're then to draw from that a line such that this angle here was 30 degrees, and this angle here was 60 degrees, obviously what we've formed here is a right angle. This is 30, this is 60, so this is 180. If we now use these angles to construct an upright, and I copy and paste that, I copy and paste this line, copy and paste this line, copy and paste this one, and this, and this again, and what I'm going to do is I'm just going to grab all of that and just bring it downwards a bit so we can see it appear in the picture. What we've now drawn is an isometric projection of a cubic structure. Now, obviously this has somewhat more three-dimensionality. Of course, what we could do is we could do the transparent back view. And again, to help us with our sense of what plane is in front, we could increase the thickness of that line, the thickness of that one, just that we begin to perceive that edge as being closest to us. And once we've created these basic mechanisms, then we can start to think about how we can use these to build more complicated objects. I'm going to select all of those for the moment and I'm going to lock them down. This is what I would call it as a space frame. So what I'm now going to do is I'm now going to use that space frame and draw into it. So if I've got an object which has a curved back, I could think about that curved back in relationship to that plane. If I was to now take that line and copy it and paste it over to the back plane, and I was then to think about its thickness, I could start to see how that would then join over here, and how that would connect at the top, and how, again, if we were to follow the plane of the object, how that might move through the center. From that, we could then start to build out from that point, thinking about where one plane joins another. We could even consider how the back might look, bearing in mind that back here this would become invisible. In the same way here, if I draw on this plane, I can visualize that, taking those points in space backwards, drawing these things like so, and seeing how they create a sense of a form in space. Again, here it's useful then to think about how one might remove certain bits of the plane that are now, of course, behind. Of course, what I'm now getting is a use of the rubber in Illustrator that I haven't necessarily wanted. I'm now going to select all of that and delete those again. So the idea of kind of using a space frame, you can begin to then think about the way that you can construct your own space frames. So as a colleague of mine used to say, what's the box that the object comes in? You can start to think about, well, is this box a kind of thin box? And I've made that a bit too big, so I'm just going to select all of that, delete it again, start off a bit lower. So this is quite a thin box. How does the object fit within the box? So we can start to think about its structure. In fact, it's closer to that back wall and more shaped in this direction. This might be the thickness of our object, and that then might come down to here. And we might then begin to realise how this top section is actually elliptical. We could look at the form that's coming off of this, and we could start to see it initially as a kind of cubic form. And then we can begin to see how that cubic form might have a more complicated structure. And at this point, when I then start to draw the more forward view, I can also then start to round up some of the structures that I'm seeing. And I've built a complicated object out of simple building blocks.